Yeah, so what I did since last time is I just basically put some order in things, corrected slightly wrong tactics that I explained last time. I just took congruence closure and union find, put them in their own modules, made them generic. So that the main file is not too huge. So it has this. Oh, it has two tuple sections. That's fantastic. Two highlights. Fantastic. Yeah, I was just not up to it yesterday. Had a big week. So yeah, put some order into this. This file is still, that's nice. This file is still 500 lines long. Yeah, you have highlights and clips. Clips are the shorter version that anybody can make, and highlights are those that you and your editors can make, I think. It's not a small file, it's not a huge file either. So what's our goal today? Our goal is to start doing actual proof. So if right now we can emit some goals during type checking, and type checking only. We're going to add. Yeah. Well, I don't come from the game really. I come to chat with you. But yeah. Where was I? I lost my train of thought. Yeah. Yeah. Sometimes I'm there late. Sometimes I'm not. But I missed your end game, so that's a bit sad. But you know. Boom, boom, boom. Yeah. So right now, the only way to generate goals is side condition during type checking. So we're going to change that as well and add some theorems that we can prove. And incidentally, in either cases, we need to be able to add some. Okay, I'm glad I left. I would be. You know, I wake up early for work. So I took the decision to, during lockdown, not move my alarm clock to be sure that I'm ready when normal life reprises next year. So that's an alarm clock at 7 o'clock. And I would not have been able to work if I had slept that late. Yeah, so we're going to add to ourselves the notion of theorems. We probably have to name axioms and theorems as well. And we're going to increasingly do things. That's going to be fast very quickly. So let's go to the grammar thing. That's the one. So a declaration can be a theorem as well. Decl equals theorem and takes a proposition. Well, that's nice. What did I do wrong this time? I said that. Oops. I'm quite. Sorry. Okay. Okay. So, syntax error at line 32 in refined. Fantastic. That's probably not the real 32. It's the 32nd line of this. So, this line. Okay, that's pretty down the line. What did I do wrong? Oh, I see. There's an extra space. Indeed. 495. Okay. Yay. We're gonna work our way through this. So now we have theorems added, but they're like exactly like axioms. I'm going to do another addition. In refined, I'm going to add successor so that we can actually axiomatize plus n times in time and start working our way up from there. Wait a second. Okay, I'm back. So what are we at? Okay, we need a new term. So somewhere I can take a natural number. I don't believe it. Where is term? Here we go. So here we can take a natural number. We're going to take a new term 1. I'm going to call it equals sucks. I said nat, but I mean sucks. For the successor. So we're going to have to add a couple of things in refined. This is so weird. Mained. I'm going to try to realign all this. Okay, that looks like it's better. Okay, line 99. So we need the subterms of sucks, and they are nothing. So we can add here. Okay, 303. Pimple. I hadn't noticed. I'm so easily amused. This is really the wrong line. Thank you. So, oh, I need vsucks here. And here, sucks, vsucks. Oops. VVV sucks. How many V's? 3, 8, 2. I'm pretty sure something else is missing, but we're gonna get back to it. We have type inference. So here it sucks, and sucks has type nat to nat. Fantastic. 461. Type infer. Find type. Oh yeah. I do have syntax for that, right? Yeah. So I can do R-type. What's the syntax again? That's the same. R-type with a capital second T, because that's fantastic. Okay, that still works, but I'm pretty sure if I go to vsucks, okay, right. That's a bit of an unfortunate situation that I have to be careful about this, but I could spell it another way. That is pure true. Okay. So now we have added the successor. So we can try to add in our program, little by little, I'm gonna add in new things. So we have defined plus, and now we're going to axiomatize plus by saying that x plus 0 equals x. Oh, I can't write it this way still. I have to figure out a way to do notations. Ooh. Error code at line 494. Okay. Is that a priority problem? No. Oh yeah, it's written proper error, please. I need to bind it, of course, for all x of type nat. I really do need proper error, please. Syntax error. Oh yeah. I'm used to cock. I want to write things like cock a bit. Okay. Now we have an axiom that plus 0 is. I'm going to add a new line here just for my sanity, and we're going to add for all x. Oops. Colon. I'm going to figure out notation. For all z, no, sorry, just these two ones for now. And I want to add, can I, okay, later. I want to do that plus x sucks y equals sucks of plus xy. Yay. I want to remove the extra parentheses there that likely have been removed by the parser. Fantastic. Isn't that fantastically great? And now we want author's definition. No, not definition, theorem. Because theorem is associativity, which is going to be annoying to write. Parsing and interpreting are so annoying. I've got no words. And I'm using something that makes it easy. Still annoying. Okay. Def axthm. I think these are like, this is more or less what lean is using. I think that the word is leaning towards that. So plus x plus yz is equal to, I'm going to do it in the other direction because I prefer it. So plus xy plus z equals this. Okay, so now I need to deal with the printing of theorems, which I can do by looking for def. And that's here. I just do this theorem printed as a keyword and a hardline. Boom! So now we have our theorem. But we want the theorem to emit a goal. How do we do that? So type check. It's a TCM. In TCM, I can emit a goal, right? So I'm just going to pretend that there's the same sort of goal as something. So I'm going to do type check first. So I'm going to emit a bunch of goals. And when the type check is done in a theorem, I'm not going to do like axiom. I'm going to do something else, something new, and I'm going to emit pay. Of course, it's already, yeah. So now we have an extra theorem. But now the problem is that we are emitting these on the whole program. That's not really what I want. And see, it has a red cross because it can't be solved automatically. This is fine. That's not exactly what I want. I'm not sure what I want. Insert fenv and do the declarations. I think the mistake is doing it in TCN. So instead of printing the program, yeah. So we don't really want to type the program this way. I want to rather do a run program thing. So let me copy this. Run is not quite what I want. But you know, val or not check in general. But it's not in TCM anymore. What's run TCM? It just returns me a list of goal and discharge status. Okay, that's good. So I'm going to put that in IO immediately. So of course it doesn't have the right type. And that is because... Ooh, I don't type check definitions. Well, that is wrong, but it doesn't matter. So we do this, that works. But this doesn't work. So here we want to do so we want to do run TCM of this. I get a bunch of goals. And when I call these goals, I'm going to print them. Which I do by pp goals. Put doc pp dot icon spell. So right now, as you might notice, I am just shuffling okay, so what's happening? Do I have Dante on? Okay. Can match IO with... No. Yeah, that's what I meant. Press the wrong button. Oh. Right, because that's pure. Oops. So right, if you don't know what's happening here, I'm just moving stuff around on my screen. Very important job. Unexpected do block in function application. That is just a no, that's not what I want to do. What I want to do is this and okay. Okay. I also modified the wrong function, of course. Sorry. Oops. Okay, so now I will retire TypeScript program eventually, I think. But in the meantime, here I just want to do run program. Check program here. This is quite fascinating. This is not at all what I was expecting. Why is it doing this? Oh, right, because I'm just putting the things. But I don't want to put it in the example anymore. I want to put it in each declaration on a line. So I want, here I want to do pp.putdoc decal pp. Shh. Okay. Okay, so I was just editing the wrong function and everything went wrong. So again, pp.putdoc $pp of decal. Right. I'll adjust in a second. So here, I want also a decal at, oops, axiom p, and I do this. And finally, decal at your MP, and I do it again. And I evidently need more hard lines. So now I can remove the pp program thing, and pp goals should possibly yeah, maybe not. I am just going to put a hard line in each of these, just this. We'll see what it does. Puts too many lines, of course it puts too many lines. Okay, well, we have some vertical space, I guess. We can deal with this. Okay. So we now have a theorem that emits a thingy. Now we will have to take an optional list of tactics. We don't really have a tactic yet. So I'm going to cheat quite a bit. So we need some base tactics. What am I going to do? Okay. I'm just going to add tactic, list of tactics, and we're going to get started. So let's do this. I'm going to add tid. That is a tactic. For now, we're going to just have one level. It's going to change soon. I don't really like the fact that levels are difficult to move about, but we're going to call it id. Max a semicolon. Term tactic. Oh. There's a tactic expression. A tactic will be the semantic of it. Easy. Okay. And we need a list of tactics, which I think there's BNFC. Let's open BNFC. I remember there's a link to the documentation here. Okay. Documentation is learn to click is a skill. LBNF macros. There's a separator. There's a separated list. I can use so tactics where I here I can type separator. We're going to use the vertical bar like in Cork. Separator and here is a tag expert. The protection for tag expert. That's because it. Yeah. I think I should keep the capital letter. Okay. And I'm going to add a new syntactic entry, which is tag alt of type tag alt, and it takes a list of tactics. And a semicolon. Okay. I don't remember if there are some specific notations for optional things, or if I just have to repeat things. So actually I want the absence of something to be equivalent to a empty list, but I don't know that there is a way to do this. Okay. So I'm going to do this, and I'm going to do that's a bit annoying. Maybe it doesn't even appear. Okay. Yeah, it seems to really not have anything about maybes. Okay then. Well, we'll do that manually. Whatever. Maybe tech out. No, where's the type? This is the type. That is just tech out. I'm going to see if I can do something better. Test type. That is just tech out. I added this is space again. And nothing tech out, which is a maybe tech out. And this is an empty thingy. But I'm wondering if I can do this. Bad coercion. So I'm really kind of forced to I'll see. Okay. And so after a theorem, I'll do that after an axiom and a definition later. I can add a maybe tag out. Everything will be false, but we're going to get there. So this is the place that I'm interested in. I should probably leave the error here. 534. Oh yeah, that's the type check program. Maybe I should just remove this. Probably will. So tax. Well, tax. I'm gonna have to do something with this. So I'm going to add me a few things. On apply, text, goal, tactic. What is my tactic type? They're just monad pluses. Okay. I need a name for these. I need a name for these. I want a shorthand, otherwise this would just be very, very annoying to repeat everywhere. Type. I'm gonna call it type tac, but it's a terrible name. I just can't find a good name on stream. Maybe. Goal, tac. Should be the tactic first. I think it should be the tactic first. The tactic, the goal, and it returns so either it is finished and then it is done, or so it will return a list of unsolved goals. Okay. And we do apply equals underscore. Okay, suppose we have this. Now I'm going to, I've already got a where close, sorry. So I'm going to do apply tax of everything is broken. Apply tac, nothing, tac out of goal, goals equals no, we can do better than this. I'm going to print every goal under some goal. We're going to do something that is almost pretty. Okay. PP. Attempted goal takes a goal, a discharge status, another discharge status, and a list of goal. We'll print it. pp.doc/pp.anti style. So pp attempted goal auto ds manual interactive ds remaining equal pp goal pp dot plus pp discharge pp auto discharge status auto ds plus pp auto discharge status, no, interactive discharge status, interactive ds, and we sort of want to make a vertical plus pp goals. Well, I think I need to group them vertically. I don't remember how it was done. I haven't saved anything in Git yet. But it's just using put doc. I don't know how I group things vertically anymore. I'm gonna try to. Here, I saved some things in Git to avoid losing everything. PP goals. I'm gonna zip remaining with open. Repeat in the prelude. Oops. Yeah, I'm missing a couple of things. So yeah, it's not quite the right type, but you will pp auto interactive. Now I want and I want to go to Windows package, pretty print. You don't see it, but my screen, something's happened. I pressed the wrong button. Sorry for the sort of interruption. That is not the package I want, but I'm going to find the right. Ooh, that is slow. So that's the one I want. Let me see if I can. Oh, there it is slow. I want another color for the auto discharge. So what's wrong with remaining? Variable not in scope remaining. Oh, indeed. Okay, I'm gonna try this blind and just write yellow here. It works. I can find a better color later. Okay. So now apply 1. We'll take a tactic and a goal with a discharge status and return the goal to discharge status. I've seen pretty good code in my life. Goal to discharge status in a list of goals. The first case is that apply 1 of the goal discharge. Oh, we have some things. Font color, color. Well, okay, that's probably not a better color. Not sure we're going to see anything in this. It's just an 8 terminal color. I can do dull. There might be ways to, because there's 16 colors. I could use color dull instead. We'll experiment a bit. Yellow is good on the dark background though, but we don't see that on screen. So G and discharge returns G discharged. Discharge because we don't have to do anything here, and the empty list. And line 1 of tac G open, that returns G open, and status and remaining, where status equals remaining equal apply tac G and status equals case remaining of the empty list, then it is discharged, and else it is open. That worked. Apply tax. Has a very similar type, but with lists. And apply tax. Right, okay. That is wrong. We just use this, and we just do this. Apply tags of empty list returns it returns the empty list. Apply tags of so you have something that's not empty list here, but I have an empty list of goal. I'm going to do an error for the moment. Too many tactics plus plus. So I'm going to call this tax length of tax too many. So if I have empty here and non-empty here, I'm just going to return empty list as well. So I'm guessing I'm just going to do this. So if there are too many goals, no, sorry, I'm wrong. So remain, so goals, I'm not going to send the empty list, I'm just going to send the remaining goals. Oh, yeah. And I'm going to map lambda g status arrow g status empty list on goals. So it conserve the same status after after interactive things if there is no extra, if there are missing tactics, I can do them incrementally. And finally, the interesting case, we have a tack and more tacks, and we have a goal. So you have two cases here, have discharged. So that's just any tax really. Not at the interesting case yet. Discharge goals, and we do goal discharged empty list colon apply tax goals. Okay. And finally, that time is the interesting case. But we've already implemented it, so that should be easy. Goal open goals. In this case, we do apply one tack goal, and we continue with apply tax tax goals. Okay, discharges, where is it written? Oh yeah. Yes. Okay. Now, have tactics. We need an extra function, apply mtax. That says maybe tac out, and then the rest of this. Apply mtax of nothing tac out equals apply tax empty list goals, apply tax of just tac out of outs of tax. I guess that's not gonna work, but I'm gonna get an error message that's gonna help me. Apply tax goals. Have the most troubles writing letters in order today. That is my fault. Oh no, I see, it's always plural, okay. Oh yeah. Right. Indeed, I need a semantics of tactics. Valtac takes a tag expr, returns a tag. And a valtac of id of tid equals tactic I need some tea. Ooh. It's called tactic.id. That doesn't make sense. If anyone is wondering, this is some nice puer tea. It's not to everybody's taste, but it is nice when you like it. This is a very fermented Chinese tea. Yeah, we're almost there. And so now we need to do this. We have a bunch of goals. So we have now the interacted goals, which is obtained by doing apply mtax tax goals, and we print how do I call them? Attempted goal. Oh, and I did the and I need to do the pp this Okay, I'm almost there. This is a bit long-winded. That's what you get when you're coding on stream. I have limited space to code and think. Where was I? Here we go. So I'm doing PP goals. I do PP attempted goals of interacted goals. And now I need to apply. So I need to do apply. So I need to remember how I do the tactic thing. Prove with. Go on M of void. So it's really not the right monad. To be able to do that, I need them to be able to return neither goal, neither list of goal. So I guess it's sort of what I want. So that should be easy. Actually, let me check something. Well, that's a monad plus in my word. Of course, either is not a monad plus. Option. Could I make something that is not void? No, I don't think so. The point is I'm returning a theorem or nothing. I'd really like to be in either. Can make my own monad and give it the monad plus things. Okay, that it's very silly that this is the main block open. Okay. I'm actually wondering whether this is making sense at all. Man, that's silly. I'm sure there's a way to do this. The problem I'm having here is that it's sort of easy to call this on all the remaining goals, but I might have errors, and the errors will just, if I like that if I put identity and there's goals left, I will see them if I aggregate the goals from the prove with function. But I also need somehow to aggregate goals when there's an error, and I don't know that there's a way to do this without refactoring a ton of code. So use M0 everywhere. I only use M0 manually. I don't use the fail tactics. Do I do the fail tactic? The fail tactic returns empty. I honestly don't really know what that would do. Might need to eventually be a bit smarter than this. Does it mean I just can't use fail? And I'm supposed to return the goal every time? It's not very modular. I think that's the only way so far. So we're going to avoid using tactic.fail for some reason, because we want our own local fail thing. Okay, so I'm going to do data tacm a equals tacm of a. Oh, that's success of a or failure of a list of goals. And so we're going to do deriving functor on this one. I don't have to write it. Okay. That was a weird effect. And we're going to do an applicative instance applicative tacm equals pure equals success and f. So there's a couple of possibilities. So success f success x equals success fx. I don't need this. So it's been it's been an hour and a half or something like this, and we haven't seen a goal yet. I'm not going to go as far as I hoped. I think I saw, oh, there's an easier way than the stupid debug.trace thing. Actually, debug.trace might not have worked. Success, failure. That's the failed goals. Returns just the failed goals. Failure. G's. And success equals also failure G's. And then they want these two failures, we just sum them together. G's prime, I don't know. Failure G's just prime. Put some spacing here. Here we go. It's not happy because it's where, yeah. Okay. Instance alternative. I don't even remember what the syntax is for this. Tag M where so there's empty, but I don't really care about it. This failure, this should not happen very often, and this, okay. And there's success. So it's going to act as the maybe monad on success, success X, or something equals success X and failure anything or the other thing. Just feels wrong. I don't know, I'll have to think about it. And an action is the action. I don't really see another way, but I sort of have to record things twice. It just doesn't make much sense. Not in scope alternative, which is in control applicative. Here we need a monad instance. So much fun. We need just to define bind. So success A bind F. Well, K, let's say, is K of A, and failure goals LGs followed by anything is just a failure. Okay, and finally there's an instance of monad plus, which is empty. Okay, and instead of maybe, I'm gonna have this be TACM. So now have a tack and have a goal, and we do prove with tack goal. Tactic to prove well. Tactic. I think maybe the fixer could have worked it. Couldn't like TACM. Well, yeah. So case of this. Have success of theorem and we return the empty list, should check the theorem really. And failure of goals, and we return the goals. Okay, and that takes goal and returns something something, so that is lambda g failure g. Why? Where was I using const? I have no idea. I didn't remove anything. Why? I'm very confused. Oh, because it's fully implied by applicative. That's what the reason is. Oh, so now we have a small, basically invisible cross. So we're gonna look at yellow. So I want to try something. So dull color yellow is probably it's not dull color. Color dull. Of course it is. Dull. So dull yellow is indistinguishable, but I want to see what dull red looks like. Okay, so yellow it is. Oops. Okay. Okay then. Now there's a bit of a difference. So I'm first going to track all this. More whip. Who cares? Now, if I go to my theorem here, and I add at the bottom of that id, I should have something different. Of course, it's not exactly what I want. I do want that to be on the bottom line. But now it says, oh, I've tried to prove it and I didn't manage to. So this is progress. But I need a better printer. PP goals, PP indent to yada yada. Maybe I need to add a line. Lead, PP annotate, PP bold. PP1 goals around PP hardline. So do I? I'm not sure I'm using this library very well. And here we go. And now for every goal, if I haven't managed to solve it, I have the list of goals that remain to be solved. Now that is quite sweet, I think. Now I need ways to solve this goal, and to solve this goal I will need induction, and I will just give myself a built-in induction tactic. T. Yes, so now in this circumstance we are going to do tactics that just gives me new goals for induction and natural number induction. So natural numbers are built in this thing anyway. I built in successor as well to avoid defining plus in terms of +1, which I find a bit annoying, but it's okay. The idea is that if we are to do an implementation of the programming language that is slightly being sort of refined as we go, the type the type nat can just use any like large integer inside. Vastly more efficient than successor, but it just uses the same thing. That being said, I have still no idea how to define totality, which will become important at some point. We just assume that everything is total, and there's this what possibly go wrong thing happening. So here are our tactics again, and we want to add some more interactive tactics, and this one that I want to do is induction. So we're just gonna go through it. So that's just, you know, for now it's induction on the natural number, no structural induction of any sorts. Okay, so induction monad plus m. Oh yeah, okay, so there will be series when I go to failures, I guess. I'll have to fix the m zeros. Not exactly sure what I want to do. Monad plus tactic goal theorem m induction. So what do we need to assume? It's a proposition on natural numbers. So it's not a tactic. It takes a name that is an ident at the time, returns the tactic, yada yada. So we just assume that this is a free identifier in the thing. Right now, goals don't keep a list of the identifiers that are free in them. Just assume that they exist and they are universally quantified, which goes fairly well in the what could possibly go wrong category as well. I don't care. Well, we'll see later. Take an identifier, we'll call it X, and we return a tactic. Tactic dot muck dollar lambda k g. K is to be called recursively on the sub goals. So we're going to say that let subs equal so we're going to do a G. So do we have a subs goal? I'm sure we don't. But we're gonna do this. Subs goal. Where are my subs functions? Ident term. So we're going to substitute X by nat 0 in what exactly? Actually, I don't want to subs the goal. I want to subs the conclusion. So I'm going to do hips, so goal, hips, concal. And so we're going to do nope. Okay, so we're going to not use subs goal after all. We're going to use hips. And we are going to use that is subs prop. Yeah, otherwise this is problematic. Substruct x0 concal. We're gonna have a second oh gosh, I hate this alignment. The second goal is more interesting. We're going to add an extra hypothesis, which is that's not, is that the conclusion? Yeah, this is hard to just do right. We'll improve. I am doing crap right now, but we'll improve. So we're adding an hypothesis, which is the thing is let's do something else. I'm going to do it a different way. I'm going to do this. I'm still going to call this way. I may have to do some checks. So, it's not concal anymore. So I've got this. I've got my my induction hypothesis H. So I just prove H like this. And yeah, so the first one is that goal hips P for all I'm failing X RNAT H. Sorry, that's an extra hypothesis here. And concal. So I enrich my my goal with this. Yeah. Eventually, I don't want that goal to appear at all. I want it to be generated, but to be forced some way to be proved by the type system, to a sort of a more declarative type system. I'm trying something a bit declarative, not too much tactic. I mean, maybe we can add tactics later, but you know, I mean, we're adding tactics like a tactic language and doing a lot of operational things so that you can have customizable things. But right now, I just want to have proofs that are fairly declarative. But we are going to get back to this. So we have an extra hypothesis. I think we should just so now we're just doing this, and here we have a new hypothesis as well, which is subst prop x. Well, actually, no, it's just age itself, and here it is subst prop x sux x in h gowl. Kind of sounds like Stargate. Ghoul. Yeah, that doesn't make any sense syntax wise. Here better. So that are my sub goals, and I'm going to call k on each of them. So well, I could just, yeah, that's just overly complicated. Yeah, so I can do, I'm wrong. I'm writing this wrong. So we do oh yeah, get it. It's fine. So lambda proved proved. I'll do the proper checks later. We return proved G, and this is my first goal. My second goal. And my third goal. And that's, I think, my my theorem. Yes, because I forgot to call k on each of these. Oh yeah. That is also true. What is the other thing I can improve? App. There we go. Okay. So now we can add a new tactic. The tag expert. I'm going to do by induction by induction on ident colon prop. With this, I'm pretty guaranteed semicolon that I'm like I can't define anything. That is horrible as far as keyword are. Now I need eval tag t int. That was int. So I was lazy. Yeah, it's probably not a good idea. We don't care. It takes an ident x and a prop p and it returns induction xp. Okay, now to our program. So we really want to prove this by induction on z, I assume. I'm going to repeat this. Oops. By induction on z. So now we have three things to prove. We have to prove. Oh. Okay, that's a problem. So we have to introduce the for roles. Now that I think of it, I only do intro on p naught. I do kind of want to do for all. Oh dear. Yeah, I'll have to do something about the x's very, very soon. P for all, because I'm completely forgetting their thingy here, their type. So that can't be very good. Yeah. That is true. I'm gonna have to add intros as a tactic as well, and then I need to add consequences. So t intros tag expert. So I don't really like intros, but like without specifying what I'm introducing, but I'm just going to do this for the time being. Yeah, so that's one thing. T then tag expert. So now we can have this oops. So that is not associative, so I need to be a bit careful. Semicolon, tag expert. So says tag intro and tag intros. That does intros. Is it the name of the? I'm not sure I call it intros. Max intros. We don't really want this eventually, but so now I need TT then. T then rather. It's a tag 1, tag 2, and that is equals tactic dot then. I forgot then. Tag 1, tag 2. That's how I called it. Of course. Okay. So first we do intros. Okay. Now we need one more tactic, which is a tactic to apply different tactics to different goals. And after that, we need actual difficult tactics. And I'm kind of worried about them. Because that already needs rewriting somehow. I thought I was prepared for today. I wasn't. Dispatch. The tag expert. Text of tag expert 1. Semicolon. And a tag alt. Here is why we didn't inline tag alt and maybe tag alt earlier. Ooh. Oh no, that's fine. That's just a typo. Okay. 598. So valtac tt So tdispatch, tac1, and and so that's a tac out. Just wish it was just a list. Well, I'm gonna call it alt. Oops. Yeah, that's not. Valid assumption, congruence, max intros. Doesn't help me much. If I do tac1 alt, do I need? Doesn't find anything. Okay. Tactic. It's called dispatch. I'm so consistent. I'm really not, by the way. I change my ideas about names and everything all the time. Eval, that's why it didn't find me anything. Attack. Okay, so now that I wrote that correctly, does it find the hole? It did find dispatch and const. That's very funny. Okay. Now we can do like id. If I do that, I should have an error. Incorrect number of goals, which is not really good, and this is good, right? Woo. Okay. I'm gonna check that in, and I'm gonna think for a second. Kind of need to implement unification right now, I think. And I don't exactly know what I want to do, but we are going to try. So what we want on the second one is simply to apply this theorem, I think. No, we want to rewrite. Ooh. Or we want to add this with plus x. We want to add this with different values, I guess. So I want to be able to import this with some values. We're gonna do that. This one we can do without rewriting, I think. Or transitivity or anything. And we're just gonna use congruence closure, but I need to be able. Okay, so another phone that was on the side just thought I was talking to it, which is hilarious. And it just popped up and it's like, do you want to know something about the coronavirus? Because of course I do. like, what is this? Gone away. Oh my god, it's like that your phone is pushing you into the sort of a media whirlwind. Oh yeah, the printing of this is bad. I suppose. But let's ignore that printing thing. I should probably, I'll figure it out. Tomorrow, I don't know. It really depends on what I do during my day. I might be there because I'm going to be tired. So if I'm around, I'll come and say hello. Have an excellent night. Sweet dreams and all that. And yep, I'm sort of trying to find my interface for adding an assumption. Yeah, good night. Yeah, so basically I have two choices. I can say, let me add in the hypothesis, like let me add in this, but knowing the value of the for all binder. Or I could try, I think I'm going to start with this, but I don't necessarily want that to be the case eventually. What I might want to do is what is it that I want to do? What I might want to do is devise a way to say, oh, I just want you to notice that plus y0 is y, for the y that I have here. I'm going to have to do a ton of type checking of all this. It's fine. And, oh my god, I just realized something. This is fantastically funny and horrible at the same time. Okay, so just realize that in this word that I'm designing right now, when you write a tactic, it should be type checked. I mean, when I write a term in tactics, it should be type checked within the environment of the current goal, which is all fine. But type checking generate goals. And for now, my goals are just a list. Or maybe we are going to have the ability to attach a list of tactics to a tactic. Not by sequencing, but like, you know, as a way to discharge all the goals in it so that we can progress, to avoid just like adding these things to the goals, which are necessary, but just like, you know, just trying to give a bit of structure so that if the number of goals changes because the type changes, we know whether it is the type checking one or the one from the tactics. Otherwise, it might be very unpleasant. It sort of makes more sense. Well, both of them can be justified in a way because all these type checking can be eliminated in formulas. So all the formulas that I write, and all the terms that I write, makes sense. I did intros wrong. That is fascinating. Forgot about something. Yes. Actually, let me start with this because that's easy. You may remember in intros, I said, oh, we forget completely about X and the type. That is not really true. Well, in intro, because, oops, okay, whatever. So here I'm going to do X, and I'm going to do that is toe here. Okay. Say, oh, they're not used, but I'm going to have to add a hypothesis to this, which is how was it called? There was a type prop subtype constraint is the constraint. So I'm adding, oops, I didn't want to do that. I'm adding constraint x toe to the hypothesis, to I forgot how to pronounce this. Couldn't match expected type term. No. It takes the type and the term in that order. Okay. Oops. What? Interesting. Yeah, I've got there's a magic jumping to a letter under my H button, and the word move is J and semicolon. So there's just like there's if I mistype from the J to the H, I have this weird movement happening. Here, you know everything. Ooh. Only if it's not true, I guess. Okay. So I do add hip. It takes a prop, a list of props, and returns a list of props, and add hip of true equals of p true equals id. That is not very good style. Of p equals p colon. Yeah, props. Okay, instead of doing this, I'm doing that was the other one that I need to do like this. Okay. Let's avoid this nonsense. I don't know why it was printing this on several lines too. I have no idea. I just wing the printing so much now. Everything looks like. I'm much more familiar with OCaml's print format sort of way with the VBox and the thing box, and it's a bit different here. And because of that, I don't have the reflex, so I need to look at the dog and spend some time. I don't want to spend some time today. I'll leave it to you. Don't worry, printing will get better. So okay, but that was just me being sidetracked, wasn't it? And the goals are in reverse order to what I was expecting. Why is that? It's interesting, but why is this? Induction. I completely lost my train of thought anyway, so I was expecting this to be applied first. If I do present them in a certain order, it'll list. So if I do this, will this reverse goal? I guess it would, but I don't know what that would be. Yeah, it does. But it isn't the right order. It should be. These are the goals from there, followed by the goals from there. Is proof with doing something wrong? I don't think so. It's just tactics. Yeah, it can't really do much more than this. So I'm supposed to evaluate the thing from left to right, and this gives you a zip, 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 maybe. Doesn't look like it. But wasn't it in the other direction just a minute ago? What did I change? Oh, the add hip thing. That doesn't make sense. No. That doesn't make sense. I don't understand. Just as an experiment, if I put the for all in the middle, will they be in the middle? No. It's doing something. This is fascinating. Like I've got the. Oh no! Wait. The for all is bottom. The middle is supposed to be the induction hypothesis now, and the bottom one is okay. So that's okay. Interesting. No. They're just in reverse order for a reason that is currently unknown. And very surprising to me. So where were we? Oh yeah, we want to add a use tactic. So I first need to name the axioms, I guess. I think. Oh dear, we have a lot of work on this before it becomes barely usable. It's fine, we've got time. It's just for fun. What was it that I wanted to do? Just that because it's already midnight, I'm not sure I want to predicate success on unification working. So I'm going to get into unification at some point slowly. So what do we want to do? We want to use tactic, but I don't exactly know how to define it yet. Let's. Nope. There's a way to get there. My God. So we want a using thing. Use thing. Stillman plus ident. No, ident. We want. Oh yeah, I wanted to give names to axioms. That was what I was wanting to start with. So now we might need more data. So refined, and I want to change the axiom to force me to give a name to these. I'm still going to use this colon. It makes sense in that case as well. Now I should have syntax errors. Because my axioms, that's plus x0 search. Well, that doesn't have any meaning. Okay. Well, actually. Okay. So env. What's renv? I wonder what's happened. Map from identifiers to R types, and it is used. Throughout type check, but then I want something a bit more for check program. I think I'm going to retire type check program, which doesn't make any sense anymore. So for check programs, I need an extra argument, which is my lists of, well, axioms now and theorems soon. So I want another type, which is my theorem env, which is a map from idents to props. I'm pretty sure. And so here I have a name, which I don't want to call it X. I'm going to call it something else. What am I going to call it? I'm gonna Z. I don't know. That's silly. Define but not used. That is good. Right. There's more important things here. Theorem env is taken here, and it is passed in Go as well. There's a tenv0, tenv0. I keep them separate because it's just like overall easier. Not to I'm just passing the tenv here without modifying it, but here I am going to extend it. Map.insert. No, I don't know what this L. That's interesting. Map.insert ZP tnv. Oops. Here and here. I'm gonna ignore it for the time being and change it later. Isn't that fantastic? And I need a tnv here, so I'm not ignoring it. I'm just not extending it. Still not happy. Oh, yeah. Now the thing is, we're going to change TAC-M. Because I need to have an environment that I can refer to with all these axioms and stuff. So I need to be able to name them and to retrieve their values. Well, that isn't avoidable. So when I define it TAC-M, I'm gonna rename everything. That's interesting. That is not what I want. Oops. No. Yes. TAC-M with res-m. Type. TAC-M equals reader t of what was it? Theorem and TAC-M. Oh yeah, I meant res-m. Sort imports. I could just jump there. Now, apply doesn't needs a ranv theorem. I'm sorry. And it will use run reader t of t of this and of tnv. The arguments are in the wrong order always. Okay, and now I've got to pass tnv to it. So apply one takes it tnv theorem env tnv, and it is passed to apply. Then I need an extra tnv there. Tnv, but these ones don't really matter. Actually, I'm just do this, and I'm going to do tnv here. Tnv is wrong. Okay, and here we need, oops, First one doesn't really use it. There are still more things. TN. Okay. Okay, now we can use. The type of my tactics are overly general. Not that one. I'm just going to. I mean, it can be, but who needs this to be the case? I'm going to use ident, and we're going to take a list of idents as well, which are things that I want to instantiate. Sorry, a list of terms. And I just use them in order. Assume that it's just a bunch of forals at the front. It's pretty weak. I can do better than this using some sort of unification later. But make progress first, and then we deal. Use ident term tac. We'll need G to be goal hips concal. I'm really wondering about this. Like, I have to check, have to check that the goals I receive are correct all the time. I wonder if there's a better way. Better way maybe to reconstruct. Like, instead of checking, I'll just, like doing equality throughout the goals, I just take the goals and construct the result. Though that doesn't sound very plausible, to be honest. I don't know, that sort of annoys me a bit. I will have to figure out how other people do this. So I did everything in Cog, and in Cog the situation is that you don't really care if someone tries to like have tactics that are wrong. Gives you proof, like mix up the proof, because at the end of the day you get a witness of your theorem, of your proof, and witness is type checked at the end. But here it's a bit harder. So one way is to do like Cog in a way and just like prove as things go. Just check like the theory that like instead of you get a bunch of proof G, proof G, proof J, and you use them to build something new. But the truth is, it is not very plausible, I think. So, because like you're doing induction in that case or anything. So like what else can I do? I can't really build a new goal out of these. Quite properly, so the only thing I can really do is to check for equality. Well, anyway, getting distracted. So we have a subgoal. Interesting. Subgoal. which is goal. Is going to have instantiate like xprop with age colon hips apply to concal in, well, the usual thing. But we haven't defined either instantiate or xprop. Actually, xprop I need to do, can't quite do that. I need to access the monad for this, but I'm allowed to do this, aren't I? Tactic I need. Tactic is, what is the actual type? I forget, it's compose mf. So evidently, yeah, it's compose mf. So I can always do compose. $do, and now sub. I believe that's sub like this, but we can remove the in, and we have xprop, which is, I'm just going to assume it's here. The error messages will be interesting. Actually, no, I'm supposed to just fail if it's not there. So I'm going to do yeah, I'm gonna get my tnv, which is obtained by what's it with monad reader? Why is it so slow? What is it? Read. Might be fully read. Xprop is case. It's ask. Of course, it's not read. Why would it be read? So case map.lookup x in tnv of just p then p and nothing return p and nothing m0, another thing that I need to replace in the future. Right now, if I have an error, it's gonna be, I'm pretty sure it's gonna appear as empty. It's pretty bad. Anyway, it's gonna appear as empty, so it just looked like I have finished the goal, and this is horrible. Anyway, still don't have instantiate. Shoot. Where instantiate takes a prop position in the list of term and returns a proposition. Oh yeah. So right, that is just casting this, which is a purely applicative thing, into my monad. Now I just need this. So I'm interested in the case. Again, I'm not gonna type check, so I can prove very wrong things. P for all x, ignoring this p, and like u and u's, and if I do that, I do subst prop x by u in instantiate PUs. Okay, let's call it y. It's not complete, of course. Instantiate anything with the empty list. P with the empty list equal P instantiate something else with something else equal error too many, not enough for all. Let's do that. Okay, still not good because I made a typo. Okay, I think I have no typos anymore. Okay, I've got a path error because there's this symbol, which I don't know how I put it, but that's fine. And now it's good. And now I can no, don't revert. Whoa. That would have been whipper. That would have been a problem. Okay. What are we doing? What are we doing? Oh, syntax. Now we do syntax for use. What are my tactics? Here they are. So I'm going to use ident with a list of terms. Do I have a list of terms already? No. Good. I'm going to put this colon. Oh yeah. Okay. I'm gonna make probably less useful, but you know. Okay. So now 620. Okay. So we'll tack to use tack terms equal use tack terms. I usually call them use. Let's do this. And evil tack TSUs equal use tag empty. I was getting ahead of myself. Okay. Now in this second thing, I want to say use plus x 0 with y. Which has been properly added. Use plus x0 with plus xy angling. I was going to parse, but I'm going to say that they need to be parenthesized, otherwise it's going to be awful. So I'm not going to take terms, I'm going to take term 1. That currently is. It's not very modular. Oh yeah. Interesting. Okay. So now I've got, for some reason, they're vertically aligned. I did something. It's probably my fault, but I don't know what I did. It's very funny. And now I just need to call congruence, and for that I'm just going to call a done tactic for that for the time being, but I kind of want that to happen automatically. So I'm going to add like tdone tac expert 1 done. I have a feeling that like every word in the English language is now a keyword in my language. The goal in the future will be to reduce this a little. Oh yeah, sorry. Still 620. Oops, it's fine. Oh, it's not very far. was discharged. That calls the same tactic that is automatic. Now we haven't fixed anything, we still have this goal, and it should disappear with this. What I don't know is whether this will be in the right order or not. I think I should find a way for run with to distinguish failure from failure to complete. But that's for another time. Okay. I should have like useful failures as well. Now I've got two things to prove. So now we're going to do use plus x sucks. Right, that's the wrong one. It should be the wrong one. Well, we'll see. Plus x sucks. With plus x, y, and z. Ooh. Oh, Colin. Where did that appear? In the wrong one. Yeah. Okay. I was just printed in the wrong order for some reason. Okay. And I also need use plus x sucks with so y and z, and I need another one which is use plus x sucks. It's a bit annoying. With what? So I'm gonna have here I'm gonna have s of plus yz. So I want x and plus yz. And now it should be done. Yep. Well, I mean, if they're not done, I probably don't see it. Because of bugs, and I can't quite finish this without a bit of let me check something. What happens if I do this? exactly the same thing. Oh dear, oh dear. Let's go to congruence. Let's actually make this as a slide. Whip. Beep, 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 beep. And now I'm going to go to congruence, closure. Instead of M0, I'm going to make a fail function. And I'm going to, there's a number of things that will lose their, oh, sorry. Fail will be attack, and yeah, and fail will be equal tactic.muck dollar. I can ignore the continuation, doesn't have any subgoals, but fails immediately, takes G, and it returns compose of lift of failure G. Oops. We can actually, like, later make this oh. Yeah, we actually okay, sorry. So that takes a goal. Yeah, a goal, and returns a TACAM or theorem, well, of anything really. And do fail takes of G equals the failure G. Sort of my basic failure thing. And fail is really composed of do fail G. Okay. And here I should do fail G. And here should be TACM. And here should be TAC. And here it should be TAC. And here it is not maybe. We can do that in the empty environment, never mind. And here it is what was it? As success. Okay, And now if I remove this, I should have a visible failure. Yes. I could decorate it even more to show that it has had an error. I can make yellow crosses on the one that didn't, that just, you know, I can like, it's not high. So in order to do this though, I kind of need something. The ability to recognize that there's a hypothesis that just matches this. Something simple. So I need to change something to my cabal and add a new package called unification FD. I want to do anything vaguely quickly. So we're going to do unification terms. I'm probably going to have to do some manual things very quickly actually, but for tonight, we're going to so slow. What's wrong with the internet today? I've had troubles with Stack right now, and I had trouble with GitHub in the morning, or like around midday. I don't remember. Maybe yes. No, actually, I had troubles with GitHub yesterday night. I'm wrong, but I had some other troubles today. I'm sure. Maybe it's my internet provider that is completely off. Oh, here it is. So I'm gonna have to use these shallow terms again. Well, I changed them a bit, like term view. It's become term view and it has an A here, and that's good because that's exactly what I need for unification, which was not exactly the plan, though I probably realized it when I wrote it. So I'm going to copy this. For the time being, we have a single proposition that is of matter. So we are going to implement whatever I need here. So I need class fallible. I don't care about all this. U-term. I don't care. Freeze fallible. Binding mode. I know that's not above this. Variable unifiable. That's what I need to implement. So first, cabal. And I'm going to add unification FD. Don't know whether we're going to finish this, but the idea that I have right now is to just implement a basic. So we have something that checks whether my conclusion is currently an assumption. Now we're going to check whether it's subsumed by an assumption. Just that. And by subsumed, that means is like if I instantiate a couple of for alls, it becomes correct. And so it, for now, it only works for things that are from for alls followed by equal, and we just unify both things. So let's go. We do a traversable instance unifiable term view, and this will really look like the lift relation thing, except it's not on booleans and it's a bit different. There's a maybe instead of a bool. I don't know if I can derive one from the other. There's this sort of subtlety about either A, doing some on-the-fly unification that I don't need. Actually, because actually, let me check something. I think this will work. Shoot. I'm just going to import unifiable and qualified. Yeah, I'm gonna get there. So maybe it hasn't been released. I have no idea. Can I look at the sources for that? Okay. It hasn't been released. Fantastic. Well, I'm just gonna write it down then. No generic. Boo-hoo-hoo. Where? There's a generic implementation somewhere, but apparently not released, so I'm gonna just write it and care about this later. So zip match. For now, I'm going to use the same thing. Zip match takes. Let me just copy this. Okay. And that is pure space pure vsax. I said unification. Equals pure. So this is a bit risky because I can miss it if I add new constructor, which will eventually happen. It doesn't matter that much because we will have trouble sooner than this. Because as soon as we have binders in terms, we're gonna have to make some. I don't exactly know how to do the binder thing. Do I do lambdas? Probably, because you kind of want to do maps eventually. But when we start doing lambdas, everything becomes complicated. And already there are binders anyway, because there are for alls, and as soon as the preposition will become terms, which they will, you know, so that's right, UW and right VE. Such a choice of name. Oops. Okay, and this doesn't make sense to him because that should be nothing. That was another problem, and I botched a capitalization. Yes, interesting. Sort imports. Interestingly enough, this is not redundant anymore for some reason. I haven't used it yet. Okay. We're going to go to our proofs again. This summary assumption. I'm going to do subsumes. Subsumes takes a prop, returns a prop. It takes two props and returns a ball. I'm going to say the first one, which is the second one, is the idea. Subsumes. We're going to do that. So that was my hypothesis, and that's my conclusion. And I'm going to have to go into some monad thing. So there's new var, lookup var, bind var. So we can use like str binding. There's no reason not to. There's a run function, I'm sure. Exactly. So unification. We'll run str binding $_ and this weird letters. So I need to add another. What's the duplicate? We can't see much on this, but anyway, contents. While this is happening, I'm just going to assume that this is the name of the module that I need. Import qualified control.unification.ranked.stvar as unification. Unificaton. Well, that worked. Is something showed up here? Nope. This is really, really slow. So basically want to transform h into a u-term, and so do I want to transform c and really I want to do like go hc, where go h and c why do I do this? I kind of need a substitution in h as well, so I'm going to do a substitution in the form of it's probably going to be incorrect, and there will be variable captures, but you know, subst. So first, if there's a for all here, p for all x, then I'm going to ignore this, which should be fine. P equals do v as an existential variable, unification new var, then I go x v subst should be a map, I guess. PC. What? That is extremely surprising to me. Oh. Fresh in M. Bound to the given term. That's free var. Okay. So that's free var, I think. That's the reason why it doesn't make a lot of sense. Okay, that's good. Go subst p equals uv and p equals w t equals, I said e earlier, do let u prime equal to unif term, to u term, I guess. Yeah, well, okay, to u term subst u prime equals to u term subst phi w prime equals to u term map.empty w because the for rules are not bound there. This will actually be a completely pure thing. And e prime equals 2 uterm map.mte. And there's a okay. When we have that, we just want to check whether things are unifiable. L is u prime equals w prime. R is v prime equals e prime. And we return L and R. And we also need a function to uterm, which has type so map ident I can't define the type conveniently, so I'm just going to define this. Takes a term. I'm going to define one of these. Subst equal sorry, oh yeah, I should have probably been done in unification, but it's fine. It honestly doesn't really matter. I can do that. I can give it a term. I can actually give it a type to uterm. For all v ident map ident v to that's completely it's fine. It takes a term, it returns a unification, but uterm of v term and v. Interesting. No, that's there. It's okay. It's just an alignment problem. It's term view. What? Oh. Oops. Not very elegant. I don't care. Okay, we need to just finish this now. Okay. So term view, it has a most important case is vvar x equal case lookup. So I need to kind of check what uterm is. Case map the lookup x in subst of just v, and I will return the unification dot uvar v, and otherwise this is unification dot uterm of v var x. Notning. Couldn't match expected term. Oh yeah, that's supposed to be var, not vvar here. Oh yeah, and there's more case for go, but they're all false. Boom. Not sure I'm gonna manage to finish this, but let's try. Yeah, as soon as I have binders, I don't think I can directly use this. But it's a good shortcut for today. Probably. And maybe we just find a way to abstract away the binders and do a similar abstraction. But I don't exactly know what I want to do when I have binders. So that's the question as well. Unification, new term, vvar x. A pattern match are not exhausting an equation to u term. Yeah. Don't need the substitution for nat. X equal unification to term. I'm going to just put everything in of v nat x and I'm going to say n. I don't need a to u term sucks n. This is very redundant. I think I might be able to use a traversal. Probably. I'm not sure. I think if I like make a view, then if it's a var, I do this, and otherwise I just map to u term on the it's probably I can probably compact this. No brain right now. I'm just doing the dumb thing. Sucks doesn't take an n. U term of v sucks. And finally app, which is the interesting one. To app to u term subst app uv equals unification dot u term app v app unification of to u term subst u and to u term subst v. It's a weird h here. Okay. So what if I replace assumption by subsumes in discharge? No, sorry, subsume. I need to make a subsumption tactic. Okay. So subsumption. Let's do a theorem. Subsumption takes theorem. G at goal hips concal equals do God. Any subsumes concal in hips return $proved G and assumption subsumption gowl, another Stargate thing. Fantastic. Now I want to turn in discharge, turn assumption into subsumption. Okay, I've got no fewer things so far. It isn't. Man, I hope so far so much. I'm gonna have to trace them. Let's see what happens. So import debug.trace. Before I do that, whip but subsumption doesn't appear to work. We might not be able to fix this before the end. Import debug the trace. Yeah. And now we're going to look at a couple of things. So let's open debug.trace in a few hours, because there's plenty of utilities and I never remember which. That was fast. That isn't. Let's probably trace them. Trace it, trace show, trace showed, trace tag, trace IO, trace yeah. Trace okay. Okay. So plenty of these are found. Is there a show instance here? Probably not. Yeah, there is. So I'm going to just try something. Trace trace u prime equals plus show u prime. Okay. Data term view. I think if I derive show here, I should be good. Okay. Plus. So what was it supposed to be? This plus xy and this z here. Okay. And so. Oh, sorry. Okay, so that's plus xy applied to z. That looks correct. That is absolutely fascinating. Show v1. Okay, it isn't, but let's just, you know, help it a little. No. Is there monomorphic binds? Monomorphic binds. Here we go. It was inferring a general type for this, and so it couldn't show it, but I just want it to be the same type as the rest. So I'm gonna make that. So here we are. So u prime is what I expect it to be. This is z, and this is weirder. I know this is what it should be as well, I think. No. Oh, that's W. Well, that's W. Sorry. V is right. It's x. It's plus x applied to this. Yeah. So that's okay. Yeah, vvar plus. Let me actually bad practice. That's good. Yeah, vvar. These two don't look identical. But that's just because there's extra parentheses here and there's none here. It's the same variable. Let's just oh, they're both false. What does equal means? I'm sure I just took the wrong primitive and I'm just being an idiot. Equals, equiv, unifies. Oh, that just returns a term. Yeah. Unify two terms, I'll throw an error. We're in an error? Oh. I'm going to have a problem because this is... I don't know whether that... I'm not sure. Okay. So if I do this... I don't really care about the term. I don't even know why it returns a term. I've just a substitution, I guess, but I don't really care. I don't have this, and I can just oh yeah, return true, but there's something wrong. Oh, I've got an error monad here. Okay, I can force that to be maybe. Error monad. I can say this is like okay. And this is nothing. And I can do case. Of, and I can say that just unit maps to true and nothing maps to false. Does that work? Oh, countdown. Could not find my star. Because that's, oh yeah. EM means be a monad trans run maybe T. Where can I find maybe T? Transformer control monad maybe. Or control monad trans maybe, one of these. I'm not sure there's one in the MTL, and now it's slow. Okay, so the type of unifier is a bit annoying. Oh, but the thing is, okay, wait. Okay. It wants. Where am I? Starting to be late. Needs something that is monad error of E, where E is something and. And yeah, it's a view failure. So what I'm going to do, that's not going to work with this. So because of the sort of curious constraint, what I want is package accept T, which is in monad accept probably. Okay, now 31, and so I'm going to and so that would be right, and that would be left. I completely don't care about the error. Oh yeah. Seriously? What horrible type errors. What if I did run except T on the unification thing though? Instead of doing it here, I could. That's kind of annoying. I just want to. Okay, so I can. There's really no convenience function here. No. Really not. So I'm just going to do. I'm hoping it's going to be coherent. I'm going to make a function that has the type that I'm interested in, which is unify. I'm going to call it unify prime something. I'm going to just, yeah, I don't know. I'm going to remove valuable TVE. And that returns an m of many m of bool. See if I can define this. Okay. Found hole. UV equals do something equals run except T of U and V, no, except T of unification.unify UV. Okay, no need. Then the case. Right, and I ignore the result in the case of right, and I say true, and left, I also ignore the result, then I say false. And now I should have an ambiguous type error, I guess. Yeah, I am. Arising from the use of unify. The type variable E0 is ambiguous. Sorry, I should click on fallible. There's one case. Why does it need something that general too? Fallible TVE. It's gonna call fallible, but it's not very. Oops. Of course. Well, this is pretty bad as an interface, I must confess. I'm not sure that I gain time compared to writing an algorithm myself. Also, that is a bit annoying. It's unify prime, right? Oh, shoot, I removed too many things. I'm going to leave the trace for a second. I don't know why that happened. I think that worked. Guess I can remove my traces. Okay, we've proved a theorem with probably slightly buggy things, so I'm sure with some effort we can prove something that is not true. Let's just start. We've just proved commutativity. So I think that's a fairly good success. I am considering ideas to always close goals. Well, actually, no, not necessarily all the goals. I don't know how I want to do this. I don't really know. It's hard to read these tactics. I can try and deal with them later. So they're printed the right way. So we see here that this is not There's oh, this is interesting. Oh yeah, because it's the other one. It's not immediately checked, but it is checked interactively. Boom. I may want a bit of a language actually. I may want something like this. Like if I say by followed by a tactic description, then I assume that the first goal needs to be solved automatically. And if I don't, I introduce the thing, maybe. The proof, of course, is not very illuminating. So let's start writing associativity. There's no name in theorems either. That was associativity. How? It's easier because there's a single. Yes. Okay. So we'll see. So we need only 2 variables for commutativity. The theorem is easier to state, but I remember that it's harder to prove. I may be wrong. Let's try and prove this. So associativity is not proved. So again, we're going to do the introductions. So yeah, we need to prove that plus xy equals plus yx. By induction on y plus xy equals plus yx. I've got 3 things to prove, which are still printed in the reverse order for reasons that are absolutely not obvious to me. So the first one, they're not printed in the reverse order this time. I'm very confused. Okay, they're sometimes printed in the reverse order. Oh. Right, okay, so it's my distributing tactic that does something wrong. I might traverse things in the wrong order after I discharge. So I can check that later. I know what the problem is. So this one says that plus x0 equals plus 0x. You can easily prove that by induction on x. So that's what we're going to do by induction on x plus x0 equals plus 0x. Now I have three things to prove. Again, and the first one is yet again the right order, done by subsumption. Okay. Now we know that plus x0 equals plus 0x, and I want to prove that for the successor. So we're going to use I'm going to be able to replace these uses of use by sort of add a theorem using something, and it will have the ability to just discharge it. Use plus x0 plus x0 with and we want to use it with sucks x sorry, what am I supposed to read here? One of them is done. Which one is it? The first one, I guess. Right. Okay. That was the problem. So we notice that plus success 0 equal success, and also use plus plus x sucks with 0 and x. Ooh. Liking a semicolon. I don't think that's done, because now we know what does, sorry. What? Oh. Okay. Good. There's a bug in my instantiation. Okay. That's better. Avoiding captures is better. I thought that was the clever order, but I was wrong. Let's wrap this up quickly. I think we can finish this. So now we know that plus, so just check quickly because I'm tired. Type done is not solved. Okay. So plus 0 socks x socks plus 0x plus x 0 equals plus 0x. Oh. Actually, I'm seeing the problem. I need a for all here. Okay, so this one doesn't instantiate. But it should. There are still bugs. Also, there's not the right type now, is it? Why is this? Why is this not a for all? Oh, there's something missing. There was an induction. Sorry. Okay, we're approaching what we want. As we might not have changed anything. Okay. I probably need it for the general case now. I'm an idiot. I was, you know, I got confused because it's 2 in the morning. You're seeing this on the right, on the, like, I don't know, on this side, I think, but I am the DHCID screen is on my right. I don't really stare at it, but right now I need to. That's why I'm looking. I look like I'm looking away. So we calm down. Plus x0 equals plus 0x. So we have this is equal to this is equal to plus x0 I'm confused, sorry. This is sucks x, and this is sucks of plus 0x. Should have that. Also sucks of x plus 0, and x plus 0 equals x. So we need this as well. Use plus x 0 with x. And this should be done. Yeah. This is not very convenient. We need to find a better way to do these proofs. But I don't know what it is yet. Like maybe we could register some rules within congruence closure. I don't know. Some reduction rule. There would be some requirements, I guess, for this, but I don't know what that would be. Okay, so we have finally, we know that for all x plus xy equals plus yx. We have to prove it for sucks y. So what do we do? I don't think we're going to finish this. We're going to miss a tactic, and I'm not going to implement a new tactic today. For x n. So what do we want to say? Say that plus x sucks y is the same as sucks of plus xy. Oh, wait. So plus x sucks with x and y. Oops, colon y. Not user, use. Okay, so we have this. And what else do we have? Not entirely sure. Well, I haven't done an induction here. I kind of want to do that by induction on X, I guess. I can't really do that without induction if I couldn't with 0. Or can't I? So I know that plus exists. Oh, I would need another theorem, actually, which we can start proving. Wait, we should probably prove both theorems. Theorem for all x vn. I'm gonna give them name later. Plus 0x equals x. We've already proved that, so it shouldn't be too hard. It's this. I'm gonna nope. Okay. Oh yeah. So it's not exactly the same. So I'm forgetting my classics. Do I agree that I have this? Oh yeah, okay. Okay, and that's we can do this with just plus use plus x0 with actually you can do this. Oops, and that is done. Yep. And probably I don't need all that. I don't know which one I need. I need this one. Nope. I need this one. Yeah. Do I need the first one? I don't even remember where I have them, so I'm just trying. Probably not. Okay. Another theorem that we might want to prove is theorem for all x, y, x colon x and y of type n plus sux x y equals sux of plus x y. And how do we do this? we do this by intros. And we can do this by induction on y, since it's the right hand thing. We prove that plus sucks x y equals sucks plus xy. By induction. Okay. So, what are we saying? Plus sucks equals, so that's pretty easy. We just notice that plus x0 with x in 0, as well as use plus x0 with sucks x. Oh, sorry, no 0 here. It's just there's just the one with sucks x. Now we have enough knowledge to reduce everything to remove the zeros, and we're done. And finally, we need to prove that. So maybe here I need an extra for all. We'll see. We need to prove this. And I think I don't need an extra for all. Yeah, I think I'm good. So I'm going to do here, I'm going to use plus x sucks with, it's a bit hard to read, x and y, and we also use it with plus x sucks with sucks x and y. It should be done. Yep. So now coming back here, I wonder if I can't here I can just use my two theorems. So use plus x0 with x, use plus 0 x with x, done. And here again, I use this. I can use plus sucks. Oh, I can't. What? That worked. This is not even defined yet. What? I'm so ahead of myself. Why did it work? Oh, I think it's just like because it's a failure, but the okay. The goal is to do that. X with X and Y, and that will be done. But right now it doesn't work, so I'm gonna have. Oh my god, it works. Oh, the huge buggy T. This is a bug. I don't have a way to add comments right now. That's good. We'll fix later. This is the right thing, though I need, of course, to name these two theorems with these names. They can be used. This just does simplification, and it does exactly what we need. Well, I think I can remove the for all and the intros, but that's for later. So that's where I'm going to cut stream. It is very, very, very late. If you've been there all the time, congratulations, and also thank you if you've been there just a little. And yeah, we do more things. There's a couple of things that can be done, like making congruence closures smarter, so that I can add some reduction rules. In it, I don't know, there's we can have some fun with associativity and commutativity, maybe, you know, having some AC unification somewhere. I really don't know yet what I want to do next. More integers, I guess, and we'll sort of build on this. We also need to type check terms that appear in tactics, so that sort of matters. And maybe we'll have to think about the interaction model a bit, because it's starting to be hard to read. Anyway, thanks a lot everybody for watching.